In this video, we're going to take a look at adding and subtracting rational expressions. And now, the idea behind adding and subtracting rational expressions is the same as fractions. There's no more rules to memorize. And I want you to understand that. It's the same thing. Oh, it tends to look different. But if you've ever driven one car, you've probably driven them all. They all tend to be the same. They just look different. Same idea. All right, so what I've done here is I've created just a little step-by-step algorithm for us to travel through. And as we do that, we're going to be taking a look at this problem over on the right side of the screen. So very first thing, whenever you're dealing with rational expressions, and if you're dealing with them for the first time, I highly suggest you factor all the denominators. If you're adding and subtracting, just factor the denominators. If you're multiplying and dividing, factor everything. All of it. Because that way it's going to make it a lot easier for you in the end. However, since we're just dealing with addition and subtraction in this particular circumstance, then we want to just factor all the denominators. Well, you'll happen to notice that my two whoa, I forgot a square. You'll happen to notice that our two denominators here are the same, and so when we get down to step 2, it says if the denominator of the expressions is different, find the LCM, or the least common multiple, and if they're the same, go to step 5. Okay, so we're going to travel all the way down here to step 5. That's, of course, after we factor all the denominators. So we need to factor these two things. So to start out with, I'm simply going to rewrite the tops. And that's all I'm going to do. Then what I can do is off on the side. So if I take a little piece of side note, or as Fermat like to use them, the margins here, I'm going to simply scroll over, create this little side note, and I'm going to work on this. I need to factor this. Now, there are oodles and oodles and oodles of different ways to factor. But if you've ever seen any of my factoring videos, I always like to run the signs. The signs are going to help me tremendously. And so because of this particular sign, I know my signs of my factors are different. And so if I have two factors, and if this thing factors at all, I know that one of them is going to be plus and one of them is going to be minus. Okay, and so I know that going into it. This is to take away a lot of those calculation things that people don't like to do. The next thing I'm going to do is I'm going to factor the front and the back into all the different possible factor pairs there could be. And then I'm simply going to ask myself, what two pairs, so here would be one pair, here's one pair, what two pairs do I have to combine to subtract to make 1, that number in front of the linear term. Notice I'm not taking the sign of linear term into context here. I'm not considering that yet. I'm just saying if I combine two of these products down here and I subtract them, do I get 1? So I have 2 times 1 is 2. 1 times 1 is 1. If I'm subtracting 2 minus 1 is 1. Okay, so that's the pairing. That means that in the blue here, my 2x and my 1x, and let me do this. I knew that they were going to be separate. I want to wait until I put them in, but I know that they're going to be different. I have 2x and 1x. Notice I'm putting the number 1 in front. You don't have to, that's fine. Also, in the back, my two values in the back are 1 and 1. And so I'm simply going to write 1 and 1. Now, when 2 and 1 multiplied, I had to get a negative. That says that the dominant product is negative. So 2 times a negative 1. And the other one is positive. And I can do these very quickly. If your mental math is not strong, let it be. Grouping is probably better off for you. If your mental math is strong and you can handle a couple of products and a sum in your head at one time, by all means, this little quick, and I've got another video on it, this little quick method is fast, very fast. The bad thing is, if it's not factorable and they're the right numbers, it may take a while to get through it to find out it's not factorable. So you got to be careful on that. But we have what we need to have. 2x plus 1, x minus 1. Okay, so I come back over here. Oop, give me a little bit more room here. And my factors underneath are 2x plus 1 and x minus 1. 2x plus 1 and x minus 1. And now that I have the same denominators, just like in fractions, in order to add or subtract fractions, you have to have identical denominators. I do. And so to do that now, I simply distribute this. What I'm going to do is I'm going to make this positive and this thing is negative. So if I write this out and combine them, I'm going to have 2x plus 5 on the top, minus 4 minus 2. So minus 4x minus 2. All divided by the common denominator of 2x plus 1 times x minus 1. Okay, so now combine the top, combine all the like terms, and that's where we are here. We are coming down here, combine the numerators as a sum. As a sum. You'll notice we wrote sum up here. Be sure to combine like terms. And then step 6, once we've done that, and so we're going to combine like terms, the 2x and the negative 4x give us a negative 2x. Then I have, in green here, I've got the plus 5 and the minus 2. This is going to give me a plus 3. All over 2x plus 1, comma, or I'm sorry, times x minus 1. And so it says in number 6, factor the numerator if possible. Well, right now we don't have any common factors in the numerator. And so what you find out is we're done. This is as far as it went. But it's not impossible, and it works just like fractions. To find the least common multiple in fractions, hey, it's easiest to take that prime factorization and just pick them out. So that's adding and subtracting rational expressions.